Hello again, physicists. Today I'm going to bring you a video on power and introduce us to the concept. I have He-Man. You are probably a little too young for this fictional character. He entertained me many a time on Saturday mornings, and he would exclaim, "I have the power," as he charged up and became the hero He-Man. So, what made him have the power in the scope of physics? Why was He-Man powerful? That is what we shall look at. Okay, in physics, power isn't really what we think of when we hear the word power. We usually associate power with electricity. You know, the power's out if we have a bad storm. Or maybe we talk about someone being powerful in the scope of they're big and they're strong. Power to us is going to have to do with mechanical work, and specifically the rate at which it is completed. Now, as a formula, power, which is noted with a capital P here, can be calculated by taking the amount of mechanical work performed and dividing it by time. Another way to find power is, we already know that if work is done by a non-conservative force like friction, that it'll cause a change in energy. So another way to think of power is, how is an object's energy changing with respect to time? Either way will work for determining how much power is being generated through a process. Really quick, let's do a dimensional analysis so we can figure out what are the units of power. Alright, so we know that our units of power will be equal to, in this case, the units of work or energy, which in both cases those are joules, divided by the units of time, which are seconds. We could go a little further and we could say that, well, a joule is also a Newton meter, so we could in further units say that a joule per second or a Newton meter per second are the units for power. But physicists, being lazy and trying to make things more complicated than they have to be, decided we're going to have a unit specifically for power, and that is the watt, which is most unfortunately denoted with a capital W as well. So you got to be careful. If you see the capital W as part of a number, like 60 capital W, that is denoting 60 watts of power. Whereas if you see a capital W in an equation, that is referring to the concept, the quantity of work. So just be careful. If you use capital W in two different ways, and they're kind of close to one another in terms of how they're introduced, don't mix them up. To exemplify the difference between work and energy, I'm going to bring in a friend and a colleague of mine that some of you may know. I'm talking about the revered statistics teacher of Westlake High School, Mr. Heath. So both Mr. Heath and myself were student athletes in high school. Mr. Heath played baseball, as you may know, and I ran track and cross country. And we always take jabs at each other about who was really the more powerful athlete. You know, I debate that it takes a certain amount of burst and power to be a runner, and he says to pitch 95-mile-per-hour fastballs, you need to be quite powerful as well. So I'm going to put physics as the impartial judge here to determine who really is more powerful. So to do this, we have a little race. I take myself and I run up 10-meter high stairs until I get to the top. It takes me 5 seconds to do that. Now, the force that is doing the work here is actually the force of me countering my own weight, which is about 700 newtons. So I'm exerting 700 newtons of force to lift myself up the stairs and displace myself 10 meters vertically in 5 seconds. Not too shabby. Mr. Heath does the same thing, but unfortunately for him, he's a little heavier than Mr. H. Not saying anything about being overweight, but Mr. Heath's just a little meatier than I am. So he does the same thing, runs up the 10-meter high stairs, displaces himself 10 meters vertically, but he has to exert a little more force since he weighs more, and he has to exert 800 newtons of force. Also, being a baseball player, he can't run as fast as I can. Sorry, kids. He takes 60 seconds to get up those stairs as opposed to my 5 seconds. So let's start by looking at how much work each of us did. For me, if we use the work formula, I would take my 700 Newton force and multiply it by the displacement of 10 meters up the stairs. Now, the force I had to exert and my displacement both would put me upward. So my cosine of theta would be 1, since it's going to be 0 degrees for the angle. And my work completed is 7,000 joules. Not bad. Alright, let's look at Mr. Heath. So he pretty much has the same displacement, but he had to exert a little more force to get himself up those stairs. So multiplying these two things together, turns out Mr. Heath, he did more work than me. 8,000 joules of work, 1,000 joules more. Looks like he has me defeated. Mr. Heath, he can do more work than me, apparently. Or does he win? Remember, I said we're going to figure out who's more powerful. And power, well, part of it depends upon how much work is being completed. It also depends on how fast you're completing that work. Let's compare our powers. So the power for myself will be the work I did divided by the time it took me to complete that work. For me, that meant 7,000 joules of work divided by a total of 5 seconds, which comes out to 1,400 joules per second, or watts. What about Slowpoke Heath? How much power did he really generate? Yeah, good for him. He had a little more work completed. 8,000 joules. But look how much time he took. He took like 60 seconds, a full minute. 12 times longer than me. So, his power really just comes out to a paltry 133 watts. Yeah, that's right. Winner, winner, chicken dinner. Mr. H, based on the contest, is more powerful. In fact, I'm about 10 times more powerful than Mr. Heath. Even though he did more work, he took over 10 times as much time to complete that work. And that's what led to him having such a lower power rating than me. So don't think of power about being how much work you can do. Don't think of it being dependent upon strength necessarily, but speed, how fast or slow this mechanical work is completed, matters just as much. Okay, I'm going to give you one additional assignment, physicists. Bring shoes that you can walk and run in for tomorrow, because we are going to do a little bit of work and we're going to find out who's most powerful in our class. Until next time, physicists, until next time.